In this video, we're going to talk about exponential function. When we talk about exponential function, the base b is real number where b cannot equal to 1. And now our exponent is variable x. And when we talk about exponential function, there are two types. First is exponential growth. And the second type is exponential decay. Let's talk about exponential growth first. Exponential growth function with base b looks like this graph right here. From left to right, the graph is growing rapidly. And notice, as x goes to negative infinity, it looks like the graph touches the x-axis, but it never does. It comes very close, but it never touches the x-axis. Therefore, the x-axis, or y equals 0, becomes the horizontal asymptote. And the graph goes through 0, 1, and as x goes to infinity, the y value goes to infinity. So domain is going to be all real numbers, and the range will be y greater than 0. Again, this happens when b is greater than 1, where the b is the base of an exponential function. Now, the second type of exponential function is exponential decay, where the base b is between 0 and 1. When that happens, when you look at the graph from left to right, the graph decreases rapidly and he slows down and he will approach 0. Again, it never touches 0, but it gets very close to 0 as x goes to infinity. Again, the graph passes through 0, 1, and the domain is all real numbers, and the range is y greater than 0. And we'll look at some examples of exponential growth and decay functions. Now let's take a look at y equals 2 to the x. What is a base? Base is 2. And 2 is greater than 1. Therefore, this is exponential growth. Now, how would you graph this? The basic way of doing it is you make a table, x and y, choose x values, let's say from negative 2 to 3, and find out the y values by plugging the x value to the exponential equation. And you have 1, 2, 3, 4, 5, 6 points. And connect those 6 points, and you will be able to sketch the curve. And using the decimals, this is how the y equals 2 to the x look like. Again, this is exponential growth. That's why the function is increasing from left to right. Now, what about y equals quantity 1 over 2 to the x? What is the base? Base is 1 over 2. And 1 over 2 is greater than 0 and less than 1. So therefore, this is an example of exponential decay. And how can we graph this? Again, you can make a table and plug in x values such as negative 3 to 2, and then find the y values and plot the 6 points. Now let's kind of review. How come when x equals negative 3, y value is 8? Well, when x equals negative 3, the y value will be quantity 1 over 2 to the negative 3. Now remember, this is the same thing as 2 to the third power. If that's a negative exponent, to make it positive, you could find the reciprocal, which is 2, and that becomes positive. So you get 8. Or you could just simply say this is the same thing as 1 over quantity 1 over 2 to the third, which is the same thing as 1 over 8. Again, that same thing as 8. Also, I want to point out that what is 1 over 2? 1 over 2 is same thing as 2 to the negative 1. So therefore, y equals quantity 1 over 2 to the x is same thing as y equals 2 to the negative 1 to the x power, which is the same thing as 2 to the negative x. So note that y equals 2 to the negative x is the same thing as y equals quantity 1 over 2 to the x. So here's a graph of y equals quantity 1 over 2 to the x power. As you can see, this is a exponential decay. Now let's graph y equals 2 to the negative x. Here's a graph of y equals 2 to the negative x. As you can see, this graph is exactly the same thing as y equals quantity 1 over 2 to the x. These two are the same exponential functions.